Okay. Um, Thank you, everyone, very much for joining uh, this section. Today we'll be discussing section 2.4 for college algebra, which deals with, we're talking more about, so this is 2.4, more on slopes. And the first thing we'll be discussing are slope and parallel lines. Okay. If two non-vertical lines are parallel, then the slopes are the same. If two non-vertical lines are parallel, then they have the same slope. And also, if two distinct non-vertical lines have the same slope, then they are parallel. So the reverse is also true. If two distinct non-vertical lines have the same slope, then they are parallel. Then they are parallel. All right. And whenever we have two distinct vertical lines with undefined slopes, then they are also parallel. So whenever we have also two distinct vertical lines, both with undefined slopes, then they are parallel. All right, so these are some important points that we need to know about the relationship between the slope and the and parallel lines and their slopes. All right, so let's look at our first example. For example, one says write an equation, write an equation of the line passing through -2, 5 and parallel to the line whose equation is y equal 3x plus 1. Express the equation in Poincare form. point slope form and slope intercept form. All right, so we are told that the line that passes through the points -2 and 5 is parallel to the line y equals to 3x plus 1. That means the slope of the line that passes through the point -2 and 5 is, so the slope of the line that passes through the point -2 minus 5 is equal to 3 because it's parallel to, because it's parallel to y is equal to 3x plus 1. So because it's parallel to this line, its slope is also 3. So using the point slope form, which is given by y minus y1 is equal to mx minus x1, we can write the equation of the point that passes through -2 and 5. So for the equation that passes through -2 and 5, -2 and 5, this will be our x1, and this y5 will be our y1. And we know our m, which is 3, so we can substitute this into the point slope formula, and so we will have y minus 5 is equal to 3x minus -2. And this equals to 3x minus -2 becomes plus +2. So this becomes, so we can expand the 3x, and obtain y minus 5 is equal to 3x. 3 times x is 3x plus 3 times 2, which is 6. And now if we add 5 on both sides, then we'll have y is equal to 3x plus 11. And this is in the point slope, this is in the slope intercept form. So this, the way we've written this here is in the slope intercept form, which you remember is y is equal to mx plus b. Okay, so let's go to the relationship between slope and perpendicular lines. So slope and perpendicular lines. All right, so if two non-vertical lines are perpendicular, if two non-vertical lines are perpendicular, let me write perpendicular. Well, if two non-vertical lines are perpendicular, then the product of their slope is -1. which means the slope of the first line, if it is m1, multiplied by the slope of the second line, if it is m2, equals to -1. And also the reverse is also true. If the product of two slopes of two lines is -1, then the lines are perpendicular. And the lines are perpendicular. And also, if for a horizontal line that has the slope of 0, a horizontal line having 0 slope is perpendicular to a vertical line having a different slope. Having a different slope. All right, so let's use an example to explain some of these points. Example 2. This would be our example 2. And it says, find the slope of any line that is perpendicular to the line whose equation is x plus 3y minus 12 is equal to 0. All right, so we said if there is any other line that has a slope that is perpendicular to this line, then the product of the slopes of the two lines is equal to -1. All right, so to find the slope of this line, we have to first write it in slope-intercept form. And so let's write this is in slope-intercept form. So if we subtract x on both sides, we have 3y minus 12 is equal to -x. And if we add 12 from both sides, then we have 3y is equal to -x plus 12. And if we divide through by 3, then we have y is equal to -1/3 x plus 4. So the slope of this line is -1/3 minus 1/3. So the slope of this line is this -1/3. Okay. So if there is any other line that is perpendicular to this line, then the product of their slope should be equal to -1. So we have, if the slope of this line is m1 times the slope of the line we are trying to find is m2, the product of the two should equal to -1. And we know the slope of this first line here, which is m1. So -1/3 times the slope of the second line, which we are trying to find, is equal to -1. Slope. So this times m2 is equal to -1. So if we multiply both sides by 3, then we'll have -m2 is equal to -3. And if we divide both sides by -1, so we have the slope of the second line, m2, is equal to 3. So slope of the second line is slope of the second line that is perpendicular to the first line. So this is line 1. And the slope of line 2 is this. Slope of the second line is 3. All right, so let's look at another example. Okay, so this should be our example 2b. And it says write the equation of the line write the equation of the line passing through -2, -6, and perpendicular to the line. Whose equation whatever the line whose equation is x plus 3y minus 12 is equal to 0. So we found out in the previous example that the slope of a line that is perpendicular to x plus 3y minus 12, if you recall, m2 is equal to 3. So that we have a line that passes through the point -2 and -6 and is perpendicular to this line here. And we know because it's perpendicular to this line, its slope is 3. All right, so we can use the point slope formula. Y minus y1 is equal to mx minus x1 to obtain the equation of this line. So our x1 is -2, and our y1 is 6. So this becomes our x1. This is our y1. So we have y minus y1, which is -6. So y minus -6 is equal to m, which is 3 from the previous example, times x minus x1, which is also -2. So this becomes 3 times x plus 2, and we have y plus 6 is equal to 3x plus 2 All right, so we can now multiply 3 through the parentheses, which gives us 3x plus 6. So y is equal to 3x plus 6 minus 6, which equals to 3x. So the slope, um, of the equation of the line that is perpendicular to x plus 3y minus 12 is y is equal to 3x. So this is the slope of the line. Okay. All right, so let's look at slope as a rate of change. So slope as a rate of change. So example 3. So it says in 2000, the year 2000, 11.9 million young adults 11.9 million young adults lived lived with lived with their parents. In 2017, 22 million. 22 million young adults lived with their parents. Lived with their parents. And it says use this information. This information. Use this information to find slope of the line, slope of the slope of the linear function representing young adults. Young adults. living with their parents. Express the slope correct to the small places. To the small places and describe okay. So we have a pair of ordered points. We have a pair of ordered points. Our pair of ordered points are in the year 2000. We had 11.9 million young adults that lived with their family, that lived with their parents, and in the second pair of points is in the year 2017, where we have 22 million young adults living with their family. So from these two pair of points, we can find the slope. We can find the slope, and that would represent the rate of change. The slope represents the rate of change. So let's find the slope. So the slope is m is equal to y2 minus y1 divided by x2 minus x1, which equals to 22 million minus 11.9 million divided by 2017 minus 2000. And so this equals to 10.1 divided by 17, which is approximately 0.59. So what this means is the percentage of young adults living with their parents increased at the rate of, so this means the percentage of young adults living with their parents because the rate is positive, so we say it is increasing, the rate is increasing. So the percentage of young adults living with their parents increased at the rate of 0.59 a year. So every year, the rate of change is 0.59 every year. Let's also look at the average rate of change of a function. The average rate of change of a function. The average rate of change of a function. So if we say let x x1 and f of x to x1 and f of x to f of x1 and x2 and f of x to be distinct points. Be distinct points on the graph of a function f. On the graph of a function f, the average rate of change the average rate of change of L of f from x1 to x2 is given by f of x2 minus f of x1 divided by x2 minus x1. So the average rate of change is also similar to finding the slope. So we have two pair of points, x1 and its corresponding y point, which is f of x1, and x2 is corresponding y point, which is f of x2. And to find the average rate of change between these 2 points, what we do is to essentially calculate, find the slope between these 2 points. So let's look at this example here. So this should be our example 4. So it says find the average rate of change. Average rate of change for f of x equals to x cubed from x1 equals to -2 to x2 equal to 0. So to find the average rate of change of this function, we will find f of x2 minus f of x1, then we will divide by x2 minus x1. So this equals to f of x2, which is f of 0, minus f of x1, which is f of -2, divided by 0 minus -2. All right, so f of 0 is 0 cubed minus f of x, f of -2 is -2 cubed, and this divided by 0 minus -2, which becomes 0 plus 2. So this becomes 0 cubed is 0 cubed is 0. So this is 0 minus -2 cubed is -8, and this divided by 2. So this becomes 0 minus -8, which is +8 divided by 2, which is equal to 4. So this is the average rate of change between x1 equal to 2 equal to -2 to x2, which is 0. All right, so this would bring us to the end of this section, and we shall continue in the next one. All right, so see you soon.